In the yesterday's lecture, we have seen what is pre-stressing. So pre-stressing is nothing but, as you know now, we apply some stresses to the tendons. Okay, in pre-stressing for steel bars, mostly the word used is tendon. So to the steel bars or tendons, stress is applied. Okay, and due to that stress is also transferred to the concrete, and due to and that stress is applied in the opposite sense to the stress which is actually acting on that structure due to the heavy dead load and live load. Okay, so those two stresses are counteract each other, and ultimately our member sustains the load. So this type of phenomenon is known as pre-stressing. This is called as pre-stressing. Pre-stressing means we are applying the stresses. Pre means before. Okay. So now basically for pre-stressing there are two types: pre-tensioning and post-tensioning. So now one by one we will see what is pre-tensioning and what is post-tensioning. Okay. So now pre-tensioning. In pre-tensioned members, the tendons are tensioned even before the casting of concrete. Okay, so this is very simple. They have told us that in pre-tension members, the tendons means the steel bars. Okay, that the tendons are tensioned even before the casting of concrete. So before pouring the concrete, the tendons are tensioned. Okay. One end of the tendon is secured to an abutment, while the other end of the reinforcement is pulled by using a jack, and then it is fixed to another abutment. So if you see this diagram, okay, so these two are the abutments. Okay, this is our member, and then this is the jack assembly, and this is the tendon. Okay, so here the name is also given. Reinforcement has been tensioned, and then concreting has been done. Okay, so this type of assembly is there, and what they have told us, one end of the tendon is secured to an abutment. So one end of the tendon is secured to the abutment, while the other end of the reinforcement is pulled by using jack. Jack is placed, and then it is fixed to the another abutment. So in between the tendon and abutment, jack is fixed. Okay. The concrete is now poured. After the concrete has cured and hardened, the ends of the reinforcements are released from the abutment. So after pouring the concrete, these ends are released from the abutment. Okay. Then the reinforcement is now tends to regain its original length, and it's compress the concrete surrounding it by bond action. The prestress is thus transmitted to the concrete entirely by the action of bond between the reinforcement and surrounding concrete. Okay, so when you cut down this reinforcement, this steel will try to regain its original shape and size. Okay, and during that action, this steel will transfer the stresses to the concrete. Okay, and in this way, the stresses get developed in this member. Okay, so this is all about pretension. So after the pretensioning, we will move to the post tension. So now what is the post tension? A post tension member is one in which the reinforcement is tensioned after the concrete is fully hardened. Okay. So in this member, when the reinforcement, when the concrete is fully hardened, it is cured and fully hardened. After that, we provide the stress to the steel bars. Okay. The beam is first cast, leaving the duct for placing the tendons. The ducts are made by leaving the steel tubes in the concrete. So the beams are first cast, leaving the ducts by placing the tendons. So if you see this diagram, so now this is the casting of the beam. So while casting this beam, this duct is left. Okay, it is empty. Okay, why it is kept empty? So that we can insert the steel bar through this duct. Okay, so you can see the name duct. So that is what they have told us. The beam is first cast, leaving the duct for placing the tendon. Okay, the ducts are made by leaving the steel tubes in the concrete. So how these ducts are made? By placing the hollow steel tubes. So hollow steel tubes are placed in between here, and then concrete is poured. So the concrete occupies the all area whichever there, excluding this area which is occupied by the steel tube, hollow steel tube. And through that hollow steel tube afterwards, we will pass this tendons. Okay. So now the next point is, when the concrete has hardened and developed its strength, the when the concrete when the concrete has hardened and developed its strength, the tendon is passed through the duct. Okay. So after pouring the concrete, when it gets hardened, after that this tendon is placed through the duct. Okay, that is our next point. One end is provided with an anchor and is fixed to the one end of the member. Okay, so anchor and the end of the member are fixed together. Okay, so this is the anchor you can see, and the end of the member is fixed to the anchor. Okay, like this way. So now other end of the tendon is pulled by the jack, due to which the tendon compresses the concrete. So now see this other end. Now this other end is pulled by the jack. Okay, here the jack assembly is attached, and with the help of this jack, this other end is pulled. Okay. So due to which the tendon compresses the concrete. After the tendon subjected to the desired stresses, the end of the tendons is also properly anchored with the concrete. So after the this tendon is achieve the stress which we want or desired degree of the stress, then again we will cut down these tendons, or uh, we will remove this jack. Okay, and this is the diagram after removing the jack. Okay, the tendons are anchored at the ends. So these are the anchor plates. These are anchored by using the anchor plates. Okay. A distribution plate is provided at each end to avoid the crushing of concrete due to excessive bearing stress. So now when you apply the stress directly to the member, okay, so to uniformly apply that stress, we provide anchorage plate here. These are the anchor plates. So if you don't provide the anchor plates, then the cracks will be developed over here due to the excessive stress. Okay, because of these anchor plates, whatever stress we are providing over here, that is uniformly transferred to entire member. Okay, that is what given in this one. So this type of system, it is nothing but pre-tensioning system. So the basic difference between pre-tensioning and post-tensioning is, in the post-tensioning system, what you do, you tension the reinforcement after concrete has fully hardened. Okay, that is post-tensioning. Post means after, and pre-tensioning. Pre means before. You uh, tension the reinforcement before the concrete has been hardened or before the concrete has been poured in. Okay, so that is the basic difference between pre-tensioning and post-tensioning. So now after this we will move to the next point, that is the methods, systems of distressing. So all these notes I will send to our group. Okay, I will send to our WhatsApp group. From there you can download these notes and you can read. So just now, right now, just go through the procedure and understand what is pre-tensioning and post-tensioning. So doing this pre-tensioning and post-tensioning, there are several methods by which this can be done. Okay, so this is called as systems of pre-stressing. So again, these systems of prestressing are divided into two parts. First is the pre-tensioning system and second is the post-tensioning system. So the several methods we have considered over here. There are many methods, but these methods are predominantly there in our syllabus. So now, for pre-tensioning system, the first system is Hoyer system. This is for pre-tensioning system. And for post-tensioning system, the systems used as the Freycinet system, Gifford-Udall system, and Lee-McCall system. These three systems are preferably used for post-tensioning, and the Hoyer system is used for the pre-tension. So one by one, we will see all these four systems. Okay. So first is the Hoyer system. So now if you see the diagram, this is the Hoyer system. So number of members can be casted at the same time. This is the casting bed. This is called as casting bed. Okay. And a single tendon is passed through all the beams. Here the name is given beam number 1, beam number 2, beam number 3, and you can see that the tendon is passed. Here the jack assembly is there, and here the anchorage is done. Okay, and these are called as bulkheads. So or also you can call it as abutments. So now we will read one by one what is given over here. So the higher system is usually adopted for the production of pre-tension members on a large scale. Okay, so this is the important thing. So we are using this when we want to do it on a large scale. Okay. Then this method consists of stretching of wires between the two bulkheads at large distance apart. Okay. So now see here. These are the two bulkheads. The distance between the two bulkheads is very long, and in between these two bulkheads we stretch this steel wire. So this is what is given in the second point. The concrete is now poured so that the number of beams can be produced in a one line. So at a time the number of beams can be produced, so simultaneously the concrete is produced in all the members. After the concrete has hardened, the wires are released from the bulkheads. Okay. So after once this concrete is hardened, then these wires are cut down from here. For beam number 1, they will be cut down from these 2 points. For beam number 2 from these 2 points, and for beam number 3 from these 2 points. It is cut down. Okay. And after the concrete has bulkheads, the wire between the different units of the beams are also cut off. So after the concrete has hardened, the wires are released from the bulkheads. The wires between the different units of the beams are also cut off. So that is what I have told you just now. The prestress is transferred to the concrete through the bond action between the tendons and the concrete. So whatever the prestress is developed in this tendon, it is transferred to the concrete through the bond action between steel and concrete. Okay, so this is the Hoyer system. So basically, in the MCQ, the question will be there when the Hoyer system is used. So the Hoyer system is used when you want to produce the, what we can say, large scale. You want to produce the pre-stressing members on a large scale. So in that case, this Hoyer system is used. Okay. So now this is the typical diagram of Hoyer system. After that, this system is mainly used for pre-tensioning. Now we will see the systems for post-tensioning. So in the post-tensioning, the first system is Freycinet system. And if you look at the diagram, this is the diagram of Freycinet system. Okay, this is the Freycinet system. These are the female anchorage cone with steel spirals. This is the duct former. Okay, names is given. High tensile steel wires are passed through here. This is called as male cone. And now we will see how it works. The Prestress system was first to be introduced among the other post-tensioning systems. So, Prestress system is the first system which is introduced for the post-tensioning. The high-tension steel wires, 5 mm to 8 mm in diameter, about 12 in numbers, are arranged to form a group into a cable with spiral spring inside. So the wire diameter, so these are the wires. Okay, these are the high tensile wires. The diameter is from 5 mm to 8 mm. Okay, and minimum 12 number of wires, 10 to 12 number of wires will take in one cable. Okay, and such a number of cables we pass through this cone. Okay, so the spiral springs provided clearance between the wires, and thus it provides a channel which can be cement grouted. The whole thing is enclosed in a thin metal cylinder. So whole thing is enclosed in this whole thing. It is kept in the thin metal cylinder. Okay. The anchorage consists of cylinder with a central conical hole is provided with heavy reinforcement. So this is the central conical hole in which the reinforcement is provided. Heavy reinforcement is provided over here. Okay. The central hole passing axially permits the cement grout to be injected through it. Okay. Then the Prestressing force is transferred to the concrete by high tensile steel wires because of bond action. So because of the bond action, whatever the stress is developed over here in these wires, that is transferred to the concrete. So these are the diagrams of Prestress system. Okay. So afterwards you can read when I will provide these notes. You can read it in detail. This is the theoretical part. Okay. So now next is the Gifford-Udall system. The next system is the Gifford-Udall system. So for this system now, just a moment. So it consists of, so you see this, this is the diagram for Gifford-Udall system. Okay, here you can see one tube. Okay, so through that tube here the steel wire is provided, high tension steel is provided. These two are the bearing plates. Okay, this is called as split cone. This is called as split cone, and this tube is called as female cone. Okay, so the dimension is also given. What should be the dimension? It is 25 mm. What should be this dimension? It is 21 mm. Okay, and this type of system. And in detail, then diagram is given. This female cone, it look like it is like this, and here the male cone, split cone is there. It look like this. Okay, so in this split cone, this female cone is inserted. So this is the split cone, and you can see the female cone is inserted between this split cone. So ही जी जागा आहे split cone मध्ये ही left केलेली. This is the in this place this female cone is injected, and the tendons are passed through this female cone. Okay. So now we will see the arrangement. It consists of steel plate, split cone, and cylindrical female cone, anchorage to the house of the high tensile wires. Okay. The wires are stressed and anchored one by one in a separate cylinder using a small wedge. The ducts are generally formed by the metal sheets and cast into the concrete member. The bearing plates bears thrust which is cast into the concrete. So whatever may be the bearing thrust is there, that all that thrust is beared by this anchor plate. So the wires are placed through this female cone, and that female cone is then attached to this split cone, and this split cone is attached to the bearing plate. Okay, and the pressure is applied to this tendon. So this type of assembly is there to apply the pressure. Then the last system is Lee-McCall system. So you can see the Lee-McCall system. These are the different types of end plates. This is washer, this is nut, and this is the high tensile steel bar. So nut washer system is used. You can see most of our automobiles also nut and washer is used to fit the different parts. So same system is here used. Okay. So basically you understand that these are the different systems by which we can provide the pre-stress. Okay. So the tendons are used are high tensile bars, diameter varying from 12 to 40 mm, which are threaded at the end. So these bars are having threads so that it can get fit into this nut and this washer arrangement. So at the ends these bars are having threads, and these bars are basically high tensile bars, and diameter is varying from 12 mm to 40 mm. So after tensioning, each bar is anchored by screwing a nut and washer tightly against the plate. So this is the plate. So there is a nut and washer arrangement. Everybody knows what is nut and washer. Okay. So these bars are inserted through these plates, and it is fitted by using the nut and washer arrangement. Okay. So in this system, the forces are transmitted by the bearing plates at end plates. So these are the end plates, and this whole big plate, it is behind that end plate, it is the bearing plate. This is the bearing plate, and these are the end plates. Okay. So through this bearing plate, the pressure is applied to the end plate. From end plate, the pressure is transferred to this high tensile bars. It is not used for curved tendons, so it is used only for straight tendons. Okay. So the tendons whose alignment is straight, for that tendons only this is used. So basically there are two types of arrangement for the tendons. So first is this. These types of tendons are called as straight tendons, and sometimes the tendon profile is like this. These are called as parabolic tendons. These are these are called as parabolic tendons. These types of tendons are parabolic tendons, and this is the straight tendons. Okay. So these parabolic tendons are also called as curved tendons or curved bars. So Lee-McCall system is not used for the parabolic tendons; it is used for the straight tendons. Okay. So this is the information given in this unit. This is the purely theoretical unit which we are having. So some MCQs are there; those are most important. So I will tell you to write down the MCQs. So here in this unit, basically what we have seen, what is pre-stress concrete member, then why there is need to provide the pre-stress. This is the necessity. Those points I have already told you. The high compressive strength of the concrete and weak tensile strength of the concrete, and all those aspects we have already seen. Then classification of pre-stress concrete member. Basically depending upon these three, it is classified externally, internally. All these things we have discussed. Then relief and circular pre-stressing, and after that pre-tensioning and post-tensioning that we have discussed right now in this lecture. Okay, so different systems of pre-tensioning and post-tensioning also we have studied. What is pre-tensioning and what is the post-tensioning with these diagrams. Then systems of pre-stressing we have seen. For pre-tensioning, higher system is used. For post-tensioning, three systems which are given below, those are used. Okay, Prestress system, default web system, Lee-McCall system. So each of the system is given described with some points and its diagram. Okay, so this is for higher system. So important thing in the higher system is when you want to produce the pre-tension members on a large scale, then the higher system is used. This is the Prestress system. In this system, the conical arrangement is provided to give the stress to the members. Okay, so 5 to 8 mm bars are there. You can say 6 to 8 mm. 5 mm bar is not available. It is taken into the group of 10 to 12 numbers, and then the spiral cone is surrounded by it, and then the tensioning is applied. So that this type of assembly is called as Prestress system. Then G4 dural system. G4 dural system. In this system, your female cone, through the female cone, this what we can say, tendons are placed through this female cone, and this female cone is attached to the split cone, and this split cone is attached to the bearing plate, and through these bearing plates the pressure is provided to the tendon. Okay. And then Lee-McCall system, same system is there. Here bearing plate is there, end plate is also there, but nut washer is used. Okay, nut and washer is used, and whatever the steel bars we are using over here, that should be threaded at the end. So threads are provided at the end of these bars so that it can get fit into this nut and washer system. The diameter of the bar varies from 12 mm to 40 mm. So, so these are the important things in this system. And now we will move to some MCQs, and I will give you the time. You write down the MCQs, and then we will move further. So the first MCQ is, in pre-tensioning system, what is true from the following? The member is cast first, followed by the tensioning of the high tensile wires. Now we are asking about pre-tensioning. The member is prestressed by the external anchors. The high tensile wires are tensioned before the placing of concrete. And the fourth option is none of the above. That is the fourth. Or the fourth option is all of these. This type of options can be given in the examination for MCQ. So now see here, in pre-tension system, what is happening in the pre-tensioning system? So they are saying that the member is cast first, pre-tensioning, and then followed by the tensioning of the steel wires. So this is not done. This is done in post-tensioning system. Okay. So thing is that the high tension wires tension before the placing of concrete. Okay. So before pouring the concrete, we stretch the wires, we provide the pre-stress, and after that the concrete has been poured. Okay, so this is done in pre-tension system. The next is the curve cables can be used in. So curve cables means parabolic tendons. So there are basically two types of tendons used in pre-stress. First is the normal straight profile tendons, and second is the parabolic tendons, or those are called as curvy tendons. So the curvy cables or tendons can be used in. Okay, can be used in. So pre-tension members, externally pre-stressed members, post-tension members, or all of these. So the answer of this is post-tension members. In post-tension members, parabolic cables are used. Okay. So in the post-tension members also, in the that last system, this Lee-McCall system, the parabolic tendons are not used. Okay. So first thing is, parabolic tendons are used only for post-tensioning system, and the post-tensioning is done by using three methods. First is Prestress system, second is G4 dural system, and third is Lee-McCall system. Out of these three systems, in Lee-McCall system again the parabolic tendons are not used. Okay, so you remember these points for the MCQs. So after this, the next MCQ is, in a long line method or the pre-tensioning, one of the member can be cast, two members can be cast, several members can be cast. So here in a long line method, this is not or, this is off. Okay. So you can read this as, this is not or, this is off. Okay. So in long line method of pre-tensioning, long line method is the another name given to the Hoyer's method. ओके हॉयर्स मेथड किंवा हॉयर सिस्टीम जी आहे त्याचं दुसरं नाव आहे लॉंग लाईन मेथड. द अनदर नेम टू द हॉयर सिस्टीम इज लॉंग लाईन मेथड. Okay, long line. So in a long line method of pre-tensioning, only one member can be cast, only two members can be cast, several members can be cast. So the answer is several members can be cast in this fire system. Okay. So the next is in pre-tensioning system. What is the following? The wire. Now this is for pre in post-tensioning system. Okay. So wires are first tensioned followed by the concrete. Tensioning of wires and concreting is done simultaneously. The wires are tensioned against the hardened concrete. So your answer is last answer C. The wires are tensioned against the hardened concrete. So in post-tensioning system, what the options are given? Wires are first tensioned followed by the concreting. So in post-tensioning it is not done. Option A, it gives you pre-tensioning. In pre-tensioning the wires are tensioned and then followed by the concreting. Okay. Then next B option is given that tensioning of wires and concreting is done simultaneously. So simultaneously both it cannot be done. Okay. The wires are tensioned against the hardened concrete. This is done in post tension. Okay. So the last objective is the fascinate system is based on the principle of. It is based on which principle, that is most important. So this objective you should remember. Direct. It is first option is direct bearing on concrete from bolt heads at the end of the wires. It is not based on bearing. Looping of wires around the concrete. It is also not based on looping. Uh, Wedge action producing the frictional grip between the steel and concrete. So frictional grip it is get produced between the steel and concrete, due to which this precedent system is based upon that. Okay, so just wait 1 minute. Hello, लेक्चर चालू आहे मॅडम माझं. आता हां बरं बरं मी येतो लेक्चर संपवून तुमच्याकडे. हां ओके. So this is about the precedent system. Then the sixth MCQ is high tensile bars threaded at the ends are used in. So threaded bars. Okay. So these are the threaded bars. So where these threaded bars are used? So it is used in Lee Macaulay system. Okay, because there is nut and washer arrangement is there. So to fix the bar into the nut, okay, those threads are provided along the bar. So the high tensile bars threaded at the ends are used in Prestress system, Gifford system, Lee Macaulay system. So the answer is Lee Macaulay system. Okay. So the next is tendon splices are required in. So where the tendon splices are required. So Hoyer's long line method of pretensioning, short span prestressed members, long span continuous members, and none of the above. So the tension splices means the plates. It is the those are the splices means those are the plates like anchor plates. Okay, those are provided to the members so that the stress is transferred uniformly to the members. So basically, for the long span members, these splices are provided. Okay, then pre-tensioning steel has ultimate tensile strength nearly. So pre-tensioning steel has ultimate tensile strength nearly twice that of the HYSD bars. thrice that of the mild steel reinforcement, and 4 times that of the HYSD bars. HYSD bars. Okay. So HYSD bars means Fe415 and onwards. Those are HYSD bars. Mild steel bars means Fe250. So the answer is 4 times that of HYSD bar. So this much of time the strength is increased. So pre-stressing steel has ultimate tensile strength nearly 4 times that of HYSD bar. Okay, so it is 4 times. The next is pre-stressing is economical for the members of long span, medium span, short span, all of the above. So pre-stressing is economical for long span members. It is not economical for short span members. Although the pre-stressing is not economical. Okay. Whenever you go for pre-stressing, your cost of the structure and cost of the members definitely will get increased 1.5 times to 2 times. Okay, so that is why in our day-to-day routine life, now the question is that if the pre-stressing is that so much good, then why we are not using these pre-stress members in our day-to-day life structures? Okay, here we are not using the pre-stressing members. So the reason is that in pre-stressing the cost is much more. The cost of the pre-stressing is very high. It cannot be afforded by a, what we can say, by an individual. It cannot be it is not affordable to an individual. Now if we think that we will cast our house by using pre-stressing members, then it is not possible. Okay, because the cost of the construction it almost double triple. So that is why pre-stressing is generally done for the, what we can say, uh, long span structures, that is the bridges, dams, uh, these retaining walls, big retaining walls. So for these types of structures generally we do pre-stressing. Okay, it is for longer span. So linear pre-stressing is adopted in, so linear pre-stressing is adopted in circular tanks, pipes, beams. So in beams, uh, what we can say, linear pre-stressing is adopted, and in circular tanks circular pre-stressing is adopted. In pipes and circular tanks circular pre-stressing is adopted in these two, and in beams linear pre-stressing is adopted. Okay, so with this now our this theoretical unit number 5 for pre-stressing introduction, it ends. Okay. So this is, I think, very easy unit. There is nothing like a rocket science in this, so you can easily understood this once you go through these notes, and whatever explanation I have told you, that much explanation is sufficient. Okay, just you focus on the MCQ question of the lecture. So just you focus on this MCQs. Just a moment. प्रोग्रेसर आहेत का हो तिकडं? नाही आहेत का? आता त्यांच्याकडे ठेवून जरी बरं, नाहीतर ठेवून जावं इथं ड्रॉइंग, मी बघतो नंतर. मग माझं लेक्चर अजून 1 तासभर आहे. हा, माझं तर 3-3:30 पर्यंत लेक्चर कंटिन्यू चालतं. हा ठीक आहे, जाऊन येत आहे का मग? Okay, so now here these are the most important questions, MCQ questions. You can focus on these questions. And now your examination is online, so you have to be more focused on MCQs. Okay, so like last time, what you did for DCS 1, similarly you are going to do it for DCS 2. So now this is our unit number 6, next unit. So this unit is very simple, 6th unit. In this unit we are basically dealing with 3 concepts. First is the stress concept, second is the strength concept, and third is the load balancing concept. And these 3 concepts of pre-stressing we are going to use to analyze or to find out the stresses in pre-stress members. Okay, numerically we are going to find out the values. So today itself we will start this unit also. So now the heading is analysis of symmetrical and unsymmetrical section, thrust lines and cable profiles. This is our unit number 6. Okay. So some basic assumptions are there before going to the concepts. So these are the assumptions you generally make in SOM 2 also. So the transverse plane section of the member will remain plane after the bending also. This you know very well. Within the elastic limit, Hooke's law is applicable to the concrete as well as steel member. So Hooke's law is applicable within the elastic limit only. The stress in the reinforcement does not change along with the length of the reinforcement. Okay, so this is also one of the assumptions that we always do. This is also one of the assumptions that we always make in the bending stresses. M by I is equal to F upon Y is equal to E by R. Okay, in that F upon I terms, F is the stress and F upon Y. So that Y is nothing but the distance of the extreme fiber from the neutral axis. Okay. So now basically what we are going to see over here, we are going to analyze these beam structures or any structure, any prestress member, and we are going to find out the stress produced in it, level of stress, what is the stress at the top fibers of the member, what is the stress at the bottom fibers of the member, and what is the stress at neutral axis, that we are going to find out. And for finding out these stresses, we are having three concepts. First is the stress concept, second is the strength concept, third is the load balancing concept. And we will see those three concepts one by one in next lecture. Okay, so next lecture we will see this, what is the stress concept, and then we will take one numerical on stress concept, then strength concept, and after that load balancing concept. Okay, so now you drop your roll number into the chat box, and in the next lecture we will start this stress concept, unit number 6.